Okay, so today we are working on section 10.2, and we have essentially two new area formulas for three different shapes. Okay, so we're going to talk about the area of a trapezoid, the area of a rhombus, and the area of a kite. Okay? And the nice thing is these formulas aren't just abstract, they actually come from something. We said that all these formulas come from the original area formula of a rectangle, base times height, right? A triangle was half of a rectangle, therefore 1/2 base times height. Well, our two formulas today come from the area of a triangle formula. Okay, so let's take a look how that happens. So first off, we need to understand what the height of a trapezoid means. So just as a refresher, remember that a trapezoid is a four-sided figure where one pair of sides are parallel, right? And even back when we first talked about trapezoids, we called those two sides the bases, correct? The parallel sides of a trapezoid are the bases. Okay. Well, then the height of a trapezoid is that perpendicular distance between those bases. That's what we consider the height of a trapezoid. Questions, comments? All right. So, what do we do then? Well, let's take a look at a trapezoid. All right, so there's my trapezoid. I have my two bases, so this up here I'll call that base 1, this down here I'll call this base 2. I want to draw in my height, so just for the sake of argument here, I'm going to draw the height right here. So that's my height of this trapezoid. And I want to try to find the area of this guy. Okay, so if I'm going to try to find the area, currently I'm going to pretend that I don't have the formula sitting in front of me. Okay, so what if I don't know the formula? Well, then I have to break it into shapes that I know. I know how to find the area of a triangle. So if I come in here and cut this trapezoid along a diagonal, I, in essence, make two triangles, right? Okay, so let's then work this as if it's two triangles. So we have, change the size of my pen here. We have the area equals 1/2 base times height plus 1/2 base times height, because I got two separate triangles, right? Looking at the triangle that is on the bottom. So I'm looking at this triangle right here. Only looking at that triangle, what is its base? I have a variable for it. What's the variable? B sub 2. Right? B sub 2 is the base of that triangle. What's the height of that triangle? H. All right, let's plug those in. So our area is going to equal 1/2 times B sub 2 times H. Okay? All right, well then look at the other triangle. The other triangle. Now the other triangle has a base of what? B sub 1. So I can say 1/2 times B sub 1 times, well now I need to find the height. Here's the thing. If I extend out this side, see that in red, if I extend out this side, the height needs to be perpendicular to my base. And so that distance is my height right here. Right? I'm extending out that side. This is that perpendicular distance. Everyone see what I'm looking at? What is that? You're not going to be able to tell me an answer of 5 or 8 or something like that, but do we already know that length in our diagram? Yeah, we do. This segment is parallel to this segment. That means this perpendicular height is the same regardless where I draw it along those or between those parallel lines. So that means this over here is still just H. And it's the exact same H as the first triangle. They have the same height. Okay? Questions on that? Does that make sense? And again, remember the idea of a door, sliding stuff through a door? That's the height. Well, if I had a door here, if I was sliding these two triangles, again, we're still thinking of as two triangles, if I'm sliding them on the floor through this door, they can both get through that door at the exact same height. Okay, so then I can just plug in h into my formula there. All right, cool. Here's the thing. We need to remember a little bit of Algebra 1, something called factoring. And you saw this when they taught you how to add like terms. They said, well, if you have 2a plus 3a, you can factor an a out to give you 2 plus 3 times a. That's why 2a plus 3a is 5a. Yes? Yes, mine's blown. Okay. All right. So over here in our area formula, we can factor out 1/2 h. We have 1/2 h in both of those terms. And so if I pull those out front, I get 1/2 h times b sub 2 plus b sub 1. And that is the area formula they gave you for a trapezoid. Now they turned around the b1 and b2, but that's addition. That doesn't matter, right? 5 plus 2 and 2 plus 5 give me the same thing. Okay? Questions on that? All right, there's one change that I would like to make. And the reason I make this change is because I am a creature of habit, and I found out a long time ago that I learn by patterns. Okay? That's just the way my mind works. I learn by patterns. Maybe you do too. And so if we think of this, we have an area formula that says base times height. That's my phone, by the way, that's pinging, those of you hearing that. We have an area formula for a rectangle, area equals base times height. We have a triangle formula, area equals 1/2 base times height. And then we all of a sudden have a trapezoid formula that says height times base. Right? I don't like that. So I'm going to flip it around. I like everything to be in the same order if possible. I'm a creature of habit, all right? Learn by pattern. And so I would rewrite this as 1/2 times b sub 1 plus b sub 2 times h. That way it follows the same pattern as everything else. It's base first, then height. All right? If you simplify things when you're trying to memorize, it's easier to memorize. Right? Okay. So that's what I'm going to use. If you decide that you don't need that and you're just going to look off the piece of paper and the paper says the h is first, that's fine. It's the same thing. I'm not going to dock off points for something like that. Okay? Questions or comments where it comes from? No. Let's go ahead and try a problem. They don't give us a picture, but they give us all the information we need. We have a trapezoid that has a height of 7 centimeters, and the bases are 12 centimeters and 15 centimeters. Let's find its area. Area equals 1/2 times b sub 1 plus b sub 2 times height. So we have 1/2 times 12 plus 15 times 7. You could do lots of things here. You could say, I want to take 1/2 and distribute. You could say, I want to take 1/2 times 7. You could say, I want to add those two numbers. That's probably what I would do first. Okay, but as long as you're following PEMDAS, it doesn't matter which of those you do first. Okay, follow PEMDAS always. So our area equals 1/2 times 12 plus 15 is 27 times 7. Okay, so I'm seeing that we're not going to get a nice whole number answer because 27 and 7 are neither of those are divisible by 2. So what is 27 times 7? 189 halves is what I would leave this as. And there's our area. I would like you guys to try the next two with the people around you. Okay, I'll give you about a minute and a half. Ready, set, go. Taking a look at that first one. Knowing what a trapezoid looks like, if we look at the state of Nevada, this side and this side must be our bases, right? Okay. And again, this is approximate because, of course, it doesn't fill in down there, blah, blah, blah. Okay. So approximate area of Nevada. we're going to use the area of a trapezoid, which is 1/2 times b sub 1 plus b sub 2 times h. And so our area is going to be 1/2 times 205 plus 511 times 309. I find it far easier to just go ahead and add that stuff first, all right? So I'm taking 1/2 times 716 times 309. At this point, we want an approximate answer. Please pay attention to instructions. They say approximate. So what are we allowed to do? Now, we don't get those in this problem, but what are we allowed to have now? They said approximate, so it's okay if we get decimals as answers. Okay? So grab that calculator and just take 1/2 or 0.5 times 716 times 309, and what do we get for our approximate area? 110,000. I can't hear you when you talk so low. 110,000. Now everybody's talking. 622, and it is square miles. All right. Good. Questions, comments? Nope. Let's go to the next one. How many people got stuck? Honest folks. Thank you very much. Okay. This one, you're probably getting stuck here because what don't they give us? The height. All right. So our area equals 1/2 times base sub 1 plus base sub 2 times height. And so our area is 1/2 times 5 plus 7 times I don't know. We can find it. Okay. The height is going to be the same as this length right here, because that's perpendicular to our bases. But let's not use it right there. Let's draw it over here. Because that then gives us this little right triangle that we know has a 60-degree angle. So that means it's a 30-60 right triangle. So let's reminisce a little bit about what we did before Christmas. Oops. 30-60 right triangles, opposite the 30-degree angle. I know I'm drawing that small. I'll zoom in for you a little bit. Opposite the 30-degree angle is the length of 1. The hypotenuse has a length of 2. Do you remember what the long leg's length was? Square root 3. Good job. And so knowing that, we can then solve for our height. What is this length? Careful, not on our on the shortcut. You're 100% right. But what is it on our diagram? 2. This is 5. That means this length is 5. So this over here must be 2. All right. So what's our height? There you go. Good job. 2 square root 3. If you don't remember that, we did similar triangles. 1, square root 3, 2. The short leg is 2. The long leg is h. We don't care about the hypotenuse. Cross multiply. H equals 2 square root 3. All right. We need to remember some past stuff here, folks. All right. So 2 square root 3. If I was working this, and I am, I would make it easy on myself and take 1/2 of 2. And so now my area is going to be 12 square root 3 square meters. Questions? So they do ask us to change the problem a little bit down here. They say, well, what if that angle P is a 45-degree angle? And everything else stays the same. So this is still 5, this is still 7, this is still a right angle, but now this is 45. Find our area. Okay, so to do that, we're going to come in here, and again, I need to find that height. I'm going to drop this perpendicular. Looking for that height. This time, we don't have a 30, 60, 90 triangle. We have a what? 45, 45, 90. So off to the side, I'm going to remind you of that shortcut. a 45, 45, 90 triangle, the two legs had a length of 1. What was the hypotenuse? Square root 2. Okay. Well, what's the length of this segment here in that little 45 triangle in ours? 2, just like it was before. For the same reason that it was before, right? Well, then what's our height? Careful. New shortcut. 1 square root of 2. It's 2. This is going to be 2 square root of 2 if we put it in, found all the sides. Okay, 1 square root of 2. We don't need that one. We only needed the height. So our area is 1/2 times base of 1 plus base of 2 times the height. So we have 1/2 times 5 plus 7 times 2. Again, make my life easy. Multiply the 1/2 times 2. It goes away. So our area is 12 square meters. On the back side, we are now trying to find the area of rhombi and kites. Rhombi and kites. So, to know where this formula comes from, because it sounds all of a sudden totally different. We went from base times height, to all of a sudden diagonal 1 times diagonal 2. Where does that come from? Well, off to the side here, I want to draw a kite. All right, so there's my kite more or less. These sides are congruent, those sides are congruent, making it a kite. Here's the thing. In order to get the area of this kite, I need to find the area of triangles. Why? Because I know how to find the area of triangles. And so I'm going to cut it right here. Okay, if I cut it right there, and I'm going to call that diagonal 1, I now have 2 triangles. Area equals 1/2 base times height plus 1/2 base times height. Well, I now know that the base of those 2 triangles is going to be diagonal 1. That's what I'm going to use. So diagonal 1 times my height plus 1/2 times diagonal 1 times whatever height I get there. Okay? Well, let's find that height. Nice feature about both rhombi and kites is that this other diagonal is going to be bisected by that blue diagonal. Okay? So if I call that second diagonal here in red, if I call that diagonal 2, that means this length is 1/2 of diagonal 2, and this length over here is 1/2 of diagonal 2. And the last piece we need to know is that, well, those are actually perpendicular. Again, that was the property of diagonals for rhombuses and kites, is that they are perpendicular. So I can use 1/2 diagonal 2 as the height of my 2 triangles. So I can come over here and plug in 1/2 diagonal 2. And then over here, 1/2 diagonal 2. Okay, so looking at those, I want to multiply 1/2 times 1/2. We just talked about this. How do you take half of a half? What do you get? No, that's adding a half and a half. If I take half of a half, 1/4. Remember I said the other day, what was half of 3/5? It's 3/10. You just double the bottom, right? That's all we're doing here. So half of a half is 1/4. So 1/4 diagonal 1 times diagonal 2 plus, again, what's a half of a half? 1/4 diagonal 1 times diagonal 2. Okay, now we're going to addition. Now I want to add these up. So if I have 1/4 plus 1/4, what do I have? 1/2. Those of you in foods, if they ask you to double a recipe and it says 1/4 cup, do it twice, don't say, well, where's the 2/4 cup measuring spoon? No, it's 1/2. Reduce the fraction. So it's 1/2 diagonal 1 times diagonal 2, and that is where the area formula comes from. Okay? So do you have to do all of this stuff every single time? No, we did it once. We can now use that. Okay? Good deal. Let's try an example. Find the area of this kite. All right, well, we just figured out that the area is going to be 1/2 times diagonal 1 times diagonal 2. What is the length of diagonal 1? Sub-question. Does it matter which one I call diagonal 1? No. Doesn't matter at all. So what are we going to call diagonal 1? What's its length? So you said 2 plus 5. That's where you got diagonal 1. Good job. What's the length of diagonal 2? You said 3 plus 3. Good job. And so 6. Again, make your life easy. Please take 1/2 of 6. And so then our area is 21 square meters. Questions? All right, we got a little bit of work in the next one to do. A rhombus has sides of 10 centimeters, and the long diagonal is 16 centimeters. What's the area of this rhombus? So first off, let's draw a rhombus. You guys remember what's a key feature of a rhombus? What makes a rhombus a rhombus? Nope. There you go. It's a parallelogram that has all the sides that are congruent. So these are all 10 going around. And it says the long diagonal is 16. We know that for the area of this rhombus, I need 1/2 diagonal 1 times diagonal 2. So I need to know this diagonal 2 as well. Well, here's the nice thing. Remember, they're perpendicular to each other. Also, remember, they bisect each other. In a rhombus, they're bisecting each other. So that means that this side here must be 8, and this side there must be 8, because the whole length is 16, they told us. We've got to find this so that we can then add it up to get the whole thing, right? How might I go about doing that? Solve for that length how? Well, the x's are congruent, but it's not congruent to 8. What would you say? Say it louder. A squared plus b squared equals c squared. That is called the Pythagorean theorem, and that would 100% work here. Take that, plug it in. X squared plus 8 squared equals 10 squared. If you happen to remember some stuff around Christmas time, you might remember Pythagorean triples that I said, please remember. There was one particularly that I said, remember this one, if you don't remember anything else. Which one did I say to remember? 3, 4, 5. Why does that help me here? Well, it just so happens that 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. This is just a 3, 4, 5 Pythagorean triple multiplied by 2. X equals 6. I guarantee it. So that means what's the length of that diagonal? 12. So our area is going to equal 1/2 times 16 times 12. Half of 16 is 8. 8 times 12 is 96 square centimeters. So you might need to use special right triangles sometimes to find missing lengths. You might need to use the Pythagorean theorem sometimes to find missing lengths. Okay?